Hi all, this is another video about linear functions and function notation. So this is a little bit different than the group where we're finding equations based on information given in function notation. Here, I'm actually given the equation. So I know that my function f of x is the linear function 1/2 x minus 3. It has a slope of 1/2, and the y-coordinate of its y-intercept is -3. And what you'll see in the 4 parts below are that I'm asked to identify certain information about this linear function, but the questions are asked using function notation. So once again, this is really emphasizing that. Do you recognize familiar things if they're written using function notation? Okay, so the first one, f of 2 minus f of 4 divided by 2. We can actually crunch through this. We haven't done a lot of functions represented by formulas stuff yet, but I'll show you one time. But really the idea here is if we recognize what that's asking for, we shouldn't have to do any work. So let's just try it, see if we can discover what it's really asking for if you haven't already spotted it. If I want to do the work and actually crunch through this, I'm supposed to find the value of f of 6. To find the value of f of 6, we're going to plug 6 in for our input variable, and we will get 1/2 of 6, which is 3, minus 3, which is 0. Similarly, I'm supposed to find f of 4 and then subtract it from the value I just got. If I want to plug in 4, 4 is going to go in for x. I get 1/2 of 4, which is 2, minus 3, which is -1. And I'm supposed to take what I get and divide it by 2. And I can simplify a little bit here. 0 plus 1 is 1. So I'm getting 1/2. Notice, and it is not coincidence, that this 1/2 is the slope that appeared in the original equation. Once we catch on to the notation, this shouldn't be a surprise at all, because when I look at a fraction like this, I'm hoping that it immediately jumps out at you that that sort of looks like a slope. I see a y value minus a y value on the top, so the top is definitely a rise. The question you need to ask yourself is, am I dividing by the corresponding run? If you divide by the wrong number, it's not slope, but if you divide by the corresponding run, then it absolutely is slope. So here, again, function notation is great this way. We're taking f of 6 minus f of 4. So our input values are 4 and 6, which means our run is, in fact, 2. I don't know why this rise got a question mark. Which means we are looking at a slope. So even without doing the calculations, if you look at that carefully and recognize that this is saying what happens when you take your rise and you divide it by your run, and you know that the answer is you get your slope, then you can just snag this 1/2 and give it as your answer. Okay, so let's move on to a little bit messier ones, kind of in the same theme, but a little bit different. Okay, so this is a slightly more general but similar statement. This is saying if you take f of x plus 2 and subtract f of x and divide by 2, what do you get? That's the question here. Okay, so just like before, if I take f of x plus 2 minus f of x, I absolutely am looking at a rise. That makes me think that this potentially is another slope question, but I have to think about it carefully. The only way it's a slope question is if I am dividing by the appropriate run. So this has been a little less specific about what our input values are, but it was specific enough to tell me that I'm starting at some x coordinate and I'm stopping at 2 more than that x coordinate, which means that I definitely have a run of 2. So if I take my rise and I divide by my run, I should get my slope. And I don't have to do any work to find that. I already know just by looking at the equation given that my slope is 1/2. Okay, so hopefully you're hanging in there with me. I'm going to change it up just a little bit in these questions. Similar idea, but not quite the same. So slope generally is a fraction, and when I look at this one, I don't see a fraction. This is just asking me to find f of x plus 3 minus f of x for this function that I was given. So I'm definitely not looking at a question that's asking me what is the slope. I am looking at a question that's asking me what is the rise. So this is saying, what is the rise of this function? And the only way I could figure out what the rise was is if I knew what the run was, because again, I know the slope of this equation. So this isn't asking me for slope, but I do need to use slope to answer the question. The slope is 1/2, which means every time you go over 2, you should go up 1, every single time. Another way to look at that would be to say, okay, this is like 0.5 over 1, which means every time you go over 1, you should go up 1/2. And I actually think this is a slightly easier version of the slope for this problem. Because if we look back at what the question is what is your rise? How much do you go up or down? And because this is function notation, I know what run I'm supposed to use. If I'm starting at some x-coordinate x and I'm stopping at x plus 3, I know that my run is 3. So the question here is, if you go over 3, how much should you go up or down? And we know we're on the function f of x, so we know that this should follow the slope of 1/2. So I've just said that if I go over 1, I go up 1/2. This means that if I go over 2, I go up 1, and if I go over 3, I go up 1.5, which means the answer to our question is, if your run is 3, your rise should be 1.5. Okay, so just to give you a little visual on this, because I know sometimes people are really mixed up by this. We're starting at -3. Let me just get a quick graph of this line. And if we go over 2, we go up 1, over 2 more, up 1, over 2 more. Okay, so here is a section of this line. Okay, so again, the thing to realize is that linear functions have constant rates of change, so it doesn't actually matter which x-coordinate I start at. If I go over 3, I should always go up by the same amount. So if I start at, I think I missed a little bit. This is supposed to be right at 0, -3. If I start here and I go over 3, you can see that I've gone over a half. Let's see, over 1, up 1/2. I can say that right. Over 2, up another half, over 3, up another half. So if I add up all of these rises, I get a grand total of over 3, up 1.5. And if I started at a different spot on this graph, if I started at 6, 0 and went over 3, I should still get a rise of 1.5. No matter where I start on this line, I should always get this same slope triangle. If you go over 3, you go up 1.5. Okay, just one more to check and see if this is making sense. This is asking us to find f of x plus 5 minus f of x. So once again, you want to think carefully about what this is saying. It's asking you for the difference between two y values. So it's asking you for a rise. So this is similar to the last question. It's not asking you for slope, but it is asking you for rise. In order to figure out your rise, the height of your slope triangle, you need to know your run, the base of your slope triangle. So in this case, if you're starting at some x-coordinate and stopping at that x-coordinate plus 5, you know your run is equal to 5. So the question that this is really asking, and this again is all about can you recognize this question when it's asked with function notation, is when your run is 5, what is your rise? And what we know, just like before, is that every time we go over 1, we should go up a half, go up 0.5. So if we go over 5, we should go up 2.5. So the answer to our question is 2.5. Just to talk through that again, we're saying, regardless of where I'm starting on this line, I know that its slope is 1/2. So if you go over 1, you go up 1/2 or 0.5. So from any old starting point, I go over 1, up a half, over 2, up 2 halves or 1, over 3, up 1.5, over 4, up 2, over 5, up 2.5. Again, so each of these rises is a 0.5, and each of the runs was a 1, and we're looking for a grand total here. So if we scale our slope triangle up and say when we've gone over a total of 5, how much have we gone up? And it's 0.51, 1.52, 2.5. Okay, so not a coincidence that it's 5 times 1/2. That's exactly right. If your slope is 1/2, then for every 1 you go up over, you should go up 1/2. If you're going to go over 5 times, you're going to go up 5 times 1/2, or 2.5. All right, hope that made sense. I know that can be a little bit of a tricky one to get used to. Thanks for watching.